Hi again, Shylin. I'm just going to give you a quick tour of the web application side of this, which is nearing completion. Um, there we go. We just went to the website. It loads pretty quickly, and it uses this. This is actually an open source charting application that is actually intended for use with stocks, and I modified it to show real-time data with the Arduino using the WebSockets. And what you see right here, right now, is actually not the pressure. Again, because I don't have the load cells, and probably won't until I get in touch with Catino and show him what I've done so far, because he actually doesn't even know. The last thing he saw was that plastic project. Yeah, but he did change my grade from a B+ to an A, and I randomly found this book on plasticity of crystalline materials. So I'm pretty sure he knows that I've been doing work, but I haven't been able to get in touch with him. Anyway, so that's the pressure readings that it uses WebSockets. And here's the force control. You can just raise this slider, and what that'll do is that will control the solenoids. It'll actually control the force that they exert, and it works with pulse width modulation. So there's a few pins on the Arduino that you can actually control the width of each pulse from a value from 0, which would just be a low pulse. It would just be flat and low, and then 255 would be completely high pulse, and something in the middle would be 50% high, 50% low. So right now what we're going to do first is we're going to go to the analyze section, and this is actually these are datas that I pulled off the shear transducers using some filtering, and this monitors the initial ultrasonic response for the pills at the very beginning. This is what you would use to get thickness of the pill. This actually doesn't even rely on sound. It's just one of the characteristics of these transducers. Since they're so close together, they actually respond. I'm not exactly sure what kind. I think it might be magnetism or something like that. I'm not sure. So here, I'm just gonna adjust settings on this oscilloscope. Okay, and yeah, so this is supposed to be an easy way of pulling data from the oscilloscope and looking at it. So right now you can see we have the time and the value for each data, and what my little experiment right here was to look at the differences between something with super high voltage, something with lower voltage. In Catino's report, he said to use 400 volts, but here you can see this is the 400 volt response, and you can see it's a little jumpy, you know, staticky at some points. And now I'm going to turn that off, and you see that 100 volts, it actually has the same exact shape, but it's much smoother. So that would indicate that maybe we don't need to pulse a super high voltage. I think the high voltage should be used for, you know, stuff that I don't think that ultrasound is going to be able to do on Horace pills, like calculate the mass. I mean, not with our transducers. I don't think we'll be able to resonate pills. Anyway, that's a whole nother discussion. But yeah, so there we go. Data. Just going to turn these off, and I'm going to show you a quick demonstration of thickness. So we are going to acquire the waveform before. Oh, what happened here is basically a bug. I don't have all the settings properly in, and I just pulled way too many data points. But there, you see the response. That was actually just kind of lucky that I found this area right here. So before, wow, that was total coincidence. And now I'm just going to put all the pulse width modulation to max, and we're going to pull another set of data. So this, with the foam, what happened with the foam is before the transducer was just lying on top of the foam and it wasn't deformed at all. And now I have pressure being placed on the foam, which, you know, resembles a pill. It's way more porous than a pill would be. That's why I'm using it. And let's see after. Okay, so here you see this is actually just this is the right region. Actually, this is right. And by the way, this time you see at the bottom, it probably isn't right. And also, actually, the voltage is right. Somehow it pulled the voltage right, even though I really haven't finished this section, but I did want to give you a tour. So you can see the voltage on each one, and it updates in real time, and you just slide it across, and you just get a better picture of what's going on. And then you can actually zoom in. So there, and then you could kind of see, okay, maybe for fast data processing, if you're rapidly testing pills with ultrasonics, you're gonna have to use very quick algorithms that can't be sent into MATLAB for analysis, number crunching like Gaussian, who knows what, finite element analysis, I don't know, whatever. But yeah, so you can kind of see that maybe this line for this change in thickness, which was about maybe 5 millimeters before, is the green, and then after is this one. So you can use a bunch of these lines to get a thickness equation just from one point, and then you could do other things with it too. I mean, I just haven't finished programming this. You can see by like how this is not working properly. I'm actually just gonna test to see if this works. Maybe I can. Nope. Yeah, but that's another feature that will be helpful. And I'll give you a quick tour of these features. These are actually the features that I kind of wanted feedback on. So we'll go to live view. I'm gonna format this, edit it nice. Basically, right now I'm using Ajax to pull the data off the oscilloscope. But what Bristol Myers would want to do is use the Tektronix, like the oscilloscope provided driver, which interfaces with the oscilloscope at the assembly level. And if I did it, I would use Python and then compile into C. But it's definitely something that would require very low-level programming that I didn't want to deal with, because I didn't see like the return on investment worth it with this program. And also, it would take away from the simplicity of this program. Right now, this program could just be loaded on pretty much anyone's computer. Someone who doesn't have Python and doesn't want to install a 1 gigabyte driver. So that was one of the points of me making this app. And this is another incompleted section. This is what I wanted to have done until I broke the strain gauge. But this was gonna make a plot of the time of flight and the pressure. And here's stress strain diagram. This is another idea I had, since we can calculate the thickness with what I just showed you, and then we can calculate the modulus of elasticity from the time of flight, and I'll actually show you the time of flight before I call this a wrap real quick. So here I'm gonna. Okay, so right now the solenoid is still pushing in on the foam, so we're gonna see a time of flight, and there we go. Let's pull the screenshot, and there we go. That is the time of flight. So if you get, so according to Professor Coutinho, or Dr. Coutinho's research, which is pretty much what this is based off of, you can calculate the modulus of elasticity and the density and the shear modulus just by getting the time of flight for each of the two sets of transducers. And also, you know, if you make some small assumptions with two elastic modulus constants, you can get all 5 of them and just have a full profile of the pill. But I mean, you know, there's just a whole lot of different ways I can go with this. So I'd like some input from you. Like, where should I go with this? I don't know. Right now, my goal is just to work on connectivity and more automatic settings, and obviously fix that analyze section. I'm thinking about putting just like a little chart that is below the graph that just shows like wave velocity, and it'll automatically calculate the time of flight and whatnot for you. But this device, the current setup, cannot get porosity automatically because I would need a second square wave pulsar, which is like $3,000. I don't know. But anyway, this is just meant to be a small video showing you what everything's going on. When this is done, I'm probably going to make another video. It's going to take me at least an hour or two to go through the whole project. Yeah, so that's it. Alright, thanks for watching. Bye.